So, in analysis and design of algorithms, the first chapter is introduction. So, what are the topics we are going to study in the introduction is we are going to study what is an algorithm is and the fundamentals of algorithmic problem solving. So, in this video, I'm going to explain what is an algorithm is. So, coming to the definition of an algorithm is a sequence of unambiguous instructions for solving a problem. And that is nothing but for obtaining a required output for any legitimate input in a finite amount of time. So let us discuss what is this definition means. So whenever we have a problem, in order to solve that problem, we are going to write an algorithm. Then what is that algorithm? It is nothing but a sequence of instructions. So sequence means one after the another instruction. We are going to execute the instruction to solve the problem. And the instruction should be unambiguous. So whenever we write an algorithm, the very important thing is that is the unambiguous. Unambiguous means without any doubts, the instruction should be clear cut. That is what is the instruction is doing in order to solve the problem. So that is what is the meaning of unambiguous words. So here the algorithm is a sequence of unambiguous instruction for solving a problem, and what this actual means is we have to obtain the required output, that is whatever the output we require, that is the solution to the given problem for any legitimate input. That means for any valid input, that is the input whichever we are giving, that should be a valid input. That is, for example, we are going to write an algorithm to add two integer numbers means, so the numbers should be the integer numbers. So any other kind of numbers, the fraction numbers or any other things we should not give. So that is the legitimate input. We are adding two integers means the number should be the integers. So that integers becomes the legitimate input, that is we are going to provide to the algorithm, and it is going to give us the required output, and that is true in a finite amount of time. So the amount of time to run an algorithm, the algorithm is taking to run, is a crucial one here. So that is why the subject here given is not only designing an algorithm, it's also giving us to analyze the algorithm. The analysis part when we are going to study, so let us see what will be the time plays the roles. What is the role of the time in analysis of an algorithm? So here that is in a finite amount of time the output should be obtained as a solution to the given problem by taking the valid input. So that is what an algorithm is. Here there is a diagram that is going to show the notion of an algorithm. So what is this is, so whenever there is a problem, so for that one we are going to write an algorithm, and that algorithm we are going to feed it to the computer, and the computer along with the algorithm, it is going to take the input, and along with the input it is working with the algorithm, and it is going to produce the output. And this diagram is the notion of the algorithm. That is for a given problem, so we have to write an algorithm, and that needs to be fed to the computer along with the input, so that is going to produce the output, that is in a finite amount of time. Then after this definition, there are some important points we have to consider when we are going to study an algorithm, the main characteristics of an algorithm. So let us see what are those characteristics are. So here there has been listed the main 5 characteristics that is very important when we write an algorithm or study an algorithm. So the first point is the non-ambiguity requirement for each step of an algorithm cannot be compromised. That is, so each and every step, each and every instruction, whatever we are going to write, so that should be non-ambiguous, that is without any doubts. So the each and every step should be clear cut and it should contribute to solve the problem. And the range of inputs for which an algorithm works has to be specified carefully, and we have to mention for what input our algorithm is working, and we have to clearly mention for what input our algorithm is not working at all. That is, we have to mention only for what input our algorithm is working, and rest of the things our algorithm is not at all working. And the third thing is the same algorithm can be represented in several different ways. So one algorithm, so that is the procedure, everything of the algorithm, the instruction and everything will be same, but we can represent it in a different ways. And there may exist several algorithms for solving the same problem. The problem is same, but the algorithms may appear different. So there may be different kinds of algorithms, and the algorithms for the same problem that can be based on very different ideas can solve the problem with dramatically different speeds. So these are the main 5 important characteristics or the points that is related to an algorithm. So let us solve an example. That is, let us take a problem and let us examine whether really an algorithm will possess all these important points or not. So what is that example means? So the example here, whatever I have taken is, it is the example of greatest common divisor. So this is a simple example. So you may, all of you know, maybe familiar of this example. So this greatest common divisor, the definition of this is, it is a largest integer that divides both the two non-negative, both not zero integers m and n. So the greatest common divisor of two non-negative. So see here, the input for which the algorithm should work, that should be precisely mentioned. That is, we have to take two non-negative, not both zero. That means one value can be 0, not both 0 integers m and n. The two integers whichever we are taking, we are naming them as m and n, and we have to denote GCD of m comma n. So that is going to be the largest integer that divides both m and n evenly, that is nothing but with the remainder 0. That is the greatest common integer that is going to divide both m and n evenly, that is with the remainder 0. So for this problem, and here we have mentioned the input precisely. For this one, we are going to study the 3 algorithms. So see, the problem here is same, and the algorithms we are going to study are the different. So for the same problem, we are going to study 3 different algorithms, and these 3 different algorithms which I am going to explain now, that is based on completely different ideas. Okay, so see here. So the first algorithm we are going to study is the Euclid's algorithm. So what is this Euclid's algorithm is? So here there is a formula given, that is whenever we need to compute GCD of m comma n, we can replace that with the formula GCD of n comma m mod n. That is, so m we have to replace with the n value, and the n value should be replaced with m mod n value. So we keep on repeating this. So at some point we will get GCD of m comma 0. At that time we have to return m as the value of GCD of m comma 0. This is the terminating statement which terminates the problem and gives us the GCD of two numbers. For example, let us take GCD of 60, 24. So to find this GCD of 60, 24, let us apply the Euclid's algorithm. Here you can see here, so the first value is replaced by the n value, that is 24, and the second value should be m mod n, that is 60 mod 24. So what is this mod operation means? That is, mod operation is going to give the remainder, that is m mod n means m is divided by n, and whatever the remainder comes, that is the answer for it. So whenever you divide 60 by 24, so we will be getting a remainder of 12. Again apply the same formula. You can see here GCD of n has to be changed as a value of m, and m mod n, that is 24 mod n. When 24 is divided by 12, the remainder is 0. So you can see here, now the GCD of m comma 0 is equals to m. So GCD of 12 comma 0 is equals to 12, and 12 is the answer. To find the GCD of two numbers, that is the given numbers are 60 and 24. Coming to the algorithm part, so this formula, how it will be represented as an algorithm to solve the problem of finding the GCD of two numbers. So you can see here, so the first algorithm, that is written in English language, and the second algorithm, that is used in both the mixture of English language as well as the program construct. That is, whatever the while loop, for loops, any programming constructs using that one, the algorithm can be written. Both are same and both are doing the same job and both are solving the problem, but the way we are going to represent the algorithm is different. That is the important point of an algorithm. That is, both algorithms are right and both algorithms are going to give the answer, and both are based on the same concept. It is going to explain the formula, the same formula, but the way we are going to represent it is a different way. So that is what the main characteristic of an algorithm. Let us see step by step how this Euclid's algorithm works. That is, in the step 1, if n is equals to 0, you can see here. So if n is equals to 0, you can just return the value of m as the answer. Otherwise, you have to proceed to step 2. What is there in the step 2? So first we have to divide m by n and assign the value of the remainder to r. Let us take another variable that is called r. So there we are going to assign the remainder value, that is m mod n value. And then in the step 3, we are going to assign the value of n to m. So here whatever the interchange we have made, so that is assign the value of n to m and the value of r to n. So the remainder value r, that should be assigned to n, and we have to again go back to step 1. So we keep on repeating this, and when we in some point of time we will go to step 1 and we will going to make n is equals to 0. There we are going to return the value of m as the answer, and we will stop the algorithm and we will get the answer for GCD of two numbers. So this is the algorithm, that is the formula has been explained in step by step. That is a sequential procedure that is to be executed one after the other, and it is written in completely in the English language. And so the next one is the same algorithm that is written using some programming constructs of the C language particularly. So whenever we represent an algorithm, so this one we call it as in pseudocode. So in this we have to follow some of the rules, and we are going to continue these rules in the upcoming writing of the algorithms also. So what is this rules we are going to follow here when we are writing an algorithm is, so first we will write the algorithm, then we are going to write the name of the algorithm. The Euclid is the name of the algorithm, and in the brackets we are going to mention the inputs. What are the input we are going to provide it to the algorithm? And followed by this, we are going to write the three comments. The first comment is going to explain what is the aim of the algorithm. The second comment is going to explain the input we are going to give it to the algorithm. That is where we are going to mention the legitimate input for which our algorithm is working. And the third is the output, that is whatever the output we are getting from the algorithm. So let us see what is the aim of this Euclid's algorithm. That is, the aim here is to compute the GCD of m comma n by Euclid's algorithm. And what is the input we are going to give here is two non-negative, not both zero integers m and n. That is, our algorithm is working only for this input. The rest of the things, our algorithm may work correctly or it may not work properly. That is not our problem, and we are going to work only on this input, and our algorithm is working correctly, properly for this input. And the output is the greatest common divisor of m and n. So that is, when n is not equals to 0, we keep on doing this until n becomes equals to 0. So what is the things we are going to do when n is not equals to 0 is r, the remainder between when you divide m by n, that is m mod n. So you have to assign this value to r. Here the arrow mark indicates equals to. So the r will be assigned by m mod n value. And then after we have to change the m value by n and n value by r. And again we have to go back here and we have to check whether n is not equals to 0 or not. No, if n is not equals to 0, again find the m mod n value, change the m and n values, and again go back to this while loop and check the condition n whether it is equals to or not equals to 0. So when n becomes equals to 0, this while loop becomes, this condition becomes false, and we come out of this while loop and we are going to return the value of m as the answer. And this is one of the algorithm to solve the GCD of two numbers. And here we can see that we have to mention the input for which our algorithm is working. That is, precisely we have to mention. At the same time, we can represent the same algorithm in two different ways. And now let us see the another two algorithms, that is to solve the same problem, and what will be it indicating regarding the characteristics of the algorithms. So you can see here. So the next one is the consecutive integer checking algorithm. So this is another algorithm that is based on completely a different methodology to solve the GCD of two numbers, and it is completely different from the idea of Euclid's algorithm. So then what is this algorithm? Is consecutive integer checking algorithm, as the name suggests. So first thing, when we are given two numbers, that is m and n, so we have to take the smallest number among m and n, and that smallest number has to be assigned to another variable that is called t. So let us take as an example 60 and 24, and 24 is the least number, the minimum number between 60 and 24. And now we have to divide 60 by 24. If that is equals to 0, then we have to divide the second number again by 24. If that is also dividing the number completely, so then that will be the GCD of those two numbers. And we know that 60 is not divided by 24 completely. So when this condition fails, when the taken number is not dividing any one of the number completely, we have to reduce that number by 1. That is, initially we have taken the t value is equals to 24, and we have to divide m by t as well as n by t. If both m by t is equals to 0 and n by t, the remainder, is equals to 0, then that will be the greatest common divisor. No, suppose both the numbers or any of the number is not divided by t completely, means the next step is to decrease the value of t by 1. Now we have to decrease the value of t by 1, that is equals to 23. Again divide 60 by 23. No, the remainder is not equals to 0. And 24 by 23. No, the remainder is not equals to 0. So then reduce the value of 23 by 1, that is 22. So similarly, like this, we have to keep on reducing the value until what? Until we get the value 12. Because we know that for 60 and 24, the greatest common divisor is 12. That is the answer. Until 12, we keep on reducing the values from 24 to 12, one by one, and we have to keep on dividing both the values of m and n, and we have to keep on checking whether m is divided by the t value completely or n is divided by the t value completely. And finally, when we get the t value is equals to 12, 60 is divided by 12 completely, as well as 24 is divided by 12 completely, so that we will get that as an answer for GCD of two numbers, that is by consecutive integer checking algorithm. So what this example is indicating is, for the same problem we can have the two different algorithms that is based on completely different ideas. So let us see the consecutive integer checking algorithm. So here the step 1 is to assign the value, that is the minimum between m and n, to t. Divide m by t. If the remainder is this division is 0, then only go for step 3. Otherwise we have to go to step 4. So if m is divided by t completely, then only we can divide n by t. Otherwise we can just go and reduce the value of t. So the step 3 is dividing n by t. If the remainder of this division is 0, then return the value of t as the answer and stop. Otherwise, we have to proceed to step 4. What is this step 4? It is to decrease the value of t by 1, and we can go to step 2 back. And what is step 2? Again divide m by t. If that is the answer is 0, and go back and again divide n by t. And if the remainder is 0, so then we can return the value of t as the answer. Otherwise we keep on decreasing the value of t by 1 until we going to divide both m and n by the t value with the remainder 0. So then coming to another algorithm, that is the middle class procedure, which we have already studied in our school days. That is to find the prime factors of m. In the step 2, we have to find the prime factors of n. And in the step 3, we have to identify all the common factors in the two prime expansion, that what we have found in step 1 and step 2. And compute the product of all the common factors and return it as the greatest common divisor of the two numbers given. So let us see with an example here. So GCD of 60, 20, that is for 60 we have to find the prime factors. That is the only prime numbers which is going to divide 60, the factors, that is 2 into 2 into 3 into 5, that is equals to 60. And here the numbers listed all are the prime numbers. And 24 is equals to 2 into 2 into 2 into 3, and we have to take the common. So that is, you can see here 2 and 2, and again 2 and 2, and 3 and 3. So these are the common factors, and we have to multiply them, and we will get the greatest common divisor of the given two numbers. And now a question arises here, that is in the step 1 and step 2 we have just written the prime factors of m and n. And we know what are the prime numbers are. When we look at into a number, we can get to know whether the given number is a prime number or not. But when we are writing an algorithm that is to be programmed and given to the computer to solve a problem, the computer will not know what is a prime number is. So here we have to mention precisely what is a prime number is. And we have to give an algorithm to compute the prime number. Otherwise, the non-ambiguity of the algorithm instructions will going to be compromised. That is, so here we are not precisely mentioning we are having a doubt that what will be the prime numbers, and the computer is having a doubt and it is not going to know what is a prime number is. That is why we have to mention how to find the prime numbers, and for that we are going to study a simple algorithm here. So this algorithm, which is named as sieve, so sieve of n. So here we are going to get the prime numbers until the given value n. So then what is this procedure and how we are going to get the prime numbers until n is? So you can see here. So here I have listed the numbers that is starting from 2 to 25. So here the n value is equals to 25. That is till n is equals to 25. We have to list all the numbers starting with 2 because the prime numbers start from the number 2. So in the first line, I have mentioned all the numbers. What are those numbers? 2 to 25. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So you can take the n value any numbers. Okay. So after this, what is the next thing we have to do is we have to take the 2. What I have mentioned in the red color, 2. And you have to delete all the multiples of 2. That is 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. You can see in the second line. In the second line, there are no multiples of 2 are present. And then the next number will be 3. So you can see here 3, that is mentioned in the red color. Now in the next step, we have to remove the multiples of 3. So you can see here, the 9 is not here, 15 is not here, 21 has been removed, 24 is already been removed. Any of the number which has been not removed, that is a multiple of 3, will be removed. Now, coming to the next step. So what about 4? 4 has been already removed, means its multiples have already been removed also, that is by 2. So no need to remove it. No need to work on 4. Just go to the next number, that is 5. So now with the 5, we are going to remove the number, that is 25. So you can see here that 25 is not at all present here. So now we are going to remove the multiples of 5. So now, why not we have now taken the 6? So this steps we have to keep on repeating until we get square root of n. That is square root of 25 is equals to 5. So until this, we have to keep on repeating this procedure. After this, we have to stop until we get square root of 5. So until we will remove the multiples of 5. After removing the multiples of 5, we have to stop. Suppose if I have taken the number, that is square root of 27 up to 27, if I need the prime numbers, means square root of 27 will be 5 point something, and you have to take just up to 5. So if you remove the multiples of 5, then the remaining numbers here you can get is anyhow 26 will not be the prime number and 27 will also not be the prime numbers. That both numbers will be removed by their multiples of 2 as well as multiples of 3 respectively. So you will get the same numbers if we are going to get the numbers till 27 also. So in this way we have to get the prime numbers, and finally I have listed all the prime numbers, that is from 2 to 25. So let us see the algorithm, how it is going to be working. So the working of this algorithm, that is it implements the sieve of Eratosthenes, and the input is a positive integer n that should be greater than 1 because the first prime number itself is the 2, and we are going to get an array L of all prime numbers that is less than or equals to n. Up to n or less than or equals to n, we are going to get the prime values. So then how this algorithm is working? So you can see here. So this algorithm has been written with the programming constructs of the C language. So let us understand this algorithm with the help of the example which I have explained just now. That is, for p is equals to 2, that is starting from 2 to n, we will be going to write a of p is equals to p. So you can see here the first line that will be called as a of p. Okay, so this a of p is equals to p itself, that is 2 to 25. We are just listing those numbers. Now what we next do? We will next do for p is equals to 2 to square root of n do. So here you can see here how the brackets has been written. So that is, we have to get the lower value. If when we round off the values, we should get the floor value. That is, if you get the square root of 27 and we will getting 5 point something, so we have to round up it to the value 5, not for the 6. So take the lesser number, the previous round off number, and we have to check if a of p is not equals to 0. Let us see first p is equals to 2. Yes, a of p is not equals to 0. It is equals to 2. We know that. And we have to see j is equals to p into p. That is, j is equals to 2 into 2. Now, why j is less than n do? J is less than n, that is 4 is less than or equals to 25. Yes, this condition is true. Then we have to make a of j is equals to 0. What is this a of j? A of 4 is equals to 0. After that, we have to increment j with the j value plus p. We know that p value is equals to 2. So j is equals to 4 plus 2, that is nothing but 6. So what it is indicating means, so we are first taking number 4 and we are making this a of 4 is equals to 0. You can see here. So the number 4 is disappearing. Instead of making it disappearing, we are making it as 0. Then you can see here. So the j value after making a of 4 is equals to 0. So the j value has been incremented by 2. That is, now the new value of j is equals to 6. Again, we are going back to this while loop and we are checking whether j is less than n. Yes, 6 is less than 25 and we are making that value is equals to 0. That is, instead of 6, instead of making it disappear, we are making this value as equals to 0. So now again add 2 to 6. So 8 becomes 0. 8 plus 2, 10, that becomes 0. So in this way, we are making the multiples of 2 as 0. So until what this will going to be done? So you can see here, when j will become 24, 24 becomes 0. After that, again add the two values here. Now we come to the value 26. Because 26 is not in our list, we go back to this while loop and we will check whether the j value is less than n. The n value is 25, but the j value is 26. So this condition fails. We now come back to here and we will increment this for loop. That is, now p value becomes equals to 3. That means we are going to remove the multiples of 3 now. And after removing the multiples of 3, we are going to come back and increment the value of p to 4. But here there is a condition which is checking whether that a of p is equals to 0 or not. Because 4 has been already become 0, so there it checks that for the multiples of 4 we no need to make it 0, they are already became 0, right? So now after repeating this until square root of n, so we have to come to copying the given prime numbers. That is, for p is equals to 2 to n, we have to check whether a of p is not equals to 0. Then we are just copying to L of I to the numbers a of p if it is not 0. If it is 0 means, that means the number has been not there in the list of prime numbers, and we keep on incrementing the I value. After this for loop finishes, we just return the value L, that is the array L we are going to be returning. That is the array here which we are going to get as the final array, that is the array of prime numbers from 2 to 25. And this is the algorithm which going to be give us the precisely how to compute the prime numbers. So this algorithm needs to be fed to the computer in order to get the prime factors of GCD of two numbers, if you are following the middle class procedure to find the GCD of two numbers. And with this all the three methods to solve one example of finding the GCD of two numbers, we can get to know that the algorithm will have some important characteristics, and we need to follow that when we are writing an algorithm. That is, the algorithm should be having a non-ambiguous instructions, and the input needs to be clearly mentioned, and at the same time a problem will have different algorithms, and an algorithm can be represented in different ways, and algorithms that is based on different ideas will be represented differently, and that will be running in a different amount of time. So this is what is the basic of algorithm, that is with the definition and the main important characteristics or the important points about the algorithm, that is with an example. So in the next video I am going to be explaining what are the fundamental algorithmic problem solving is.